external division of a line segment. In internal division of a line segment, the point that divides the line segment lies somewhere between the endpoints of the segment, whereas in the case of the external division of a line segment, the point lies on the line containing the segment but outside the segment. The segment is extended to a certain point. Example, the line segment from point P sub 1 with coordinates -1, -2 to point P sub 2 with coordinates 2, 1 is extended a distance equal to twice its length. Find the terminal point. Let us first draw a coordinate plane. This is the y-axis. This is the x-axis. Let us plot the first point, P sub 1. Let us say this is the point. So this is point P sub 1 with the coordinates -1, -2. And let us say this is the point P sub 2 with the coordinates 2, 1. Let us connect the 2 points. So this is the line segment P sub 1, P sub 2. This is extended to a certain point. Let us represent the point by P. And let us represent the coordinates by X and Y. According to the problem, the line is extended a distance equal to twice its length. Let us represent by X the length of the given segment. So this is the X, and then by 2X, the length of the extended segment. So from P sub 2 to P is 2X. Let us determine the ratio of P sub 1, P to P sub 1, P sub 2. Let us represent by R the ratio. So R is equal to P sub 1P over P sub 1, P sub 2. P sub 1P is equal to X plus 2X, so 3X. And P sub 1, P sub 2 is equal to X. So this is equal to 3X over X. And 3X over X is equal to 3. So the ratio is equal to 3. Let us represent by X sub 1 the X coordinate of point P sub 1 and by Y sub 1 the Y coordinate of point P sub 1. Let us represent by X sub 2 the X coordinate of point P sub 2 and by Y sub 2 the Y coordinate of point P sub 2. To find the value of X, that is the X coordinate of point P, we use this formula. X is equal to X sub 1 plus R times the quantity X sub 2 minus X sub 1. We just substitute. We substitute -1 for X sub 1, 3 for R, 2 for X sub 2, and then -1 for X sub 1. So this is now equal to -1 plus 3 times the quantity 2 minus -1 becomes plus 1. So this is now equal to -1 plus 3 times 3, and this is equal to 8. So X is equal to 8. To determine the value of Y or the Y coordinate of point P, we use this formula. Y is equal to y sub 1 plus r times the quantity y sub 2 minus y sub 1, and then we just substitute. We substitute negative 2 for y sub 1, 3 for r, 1 for y sub 2, and then negative 2 for y sub 1. So we have now negative 2 plus 3 times the quantity 1. This is uh, 1 minus negative 2. That becomes 1 plus 2. So this is now equal to negative 2 plus 3 times 3, and this is equal to 7. So y is equal to 7. The terminal point is the 0.87 or 0.8 comma 7. So this is 0.8 comma 7. Let us check. To determine whether our answer is correct, we are going to find the length of the segment P sub 1, P sub 2, and the length of P sub 2, P, by using the distance formula. We are going to represent by D sub 1 the distance from P sub 1 to P sub 2. So D sub 1 is equal to the square root of the quantity x sub 2 minus x sub 1 squared plus the quantity y sub 2 minus y sub 1 squared. We substitute 2 for x sub 2, and then negative 1 for x sub 1, 1 for y sub 2, and negative 2 for y sub 1. So we have now the square root of the quantity 2 plus 1 squared plus the quantity 1 plus 2 squared. This became positive 1 because minus negative 1 becomes positive 1, and minus negative 2 is the positive 2. This is now equal to the square root of 3 squared plus 3 squared. And this is now equal to the square root of 18. 18 can be written as 2 times 9. So we have the square root of 2 times 9. And the square root of 9 is 3. So this is equal to 3 square root of 2. This is the distance from P sub 1 to P sub 2, represented by D sub 1. Let us represent by D sub 2 the distance from P sub 2 to P. So D sub 2 is equal to the square root of the quantity x minus x sub 2 squared plus the quantity y minus y sub 2 squared. Then we substitute. We substitute 8 for x and 2 for x sub 2. Then we substitute 7 for y and 1 for y sub 2. This is now equal to the square root of the quantity 8 minus 2 squared plus the quantity 7 minus 1 squared. This is now equal to the square root of 6 squared plus 6 squared. This is now equal to the square root of 36 plus 36. This is now equal to the square root of 2 times 36. And the square root of 36 is 6. So we write that outside the symbol of square root. So we have 6 square root of 2. Notice that if we multiply 3 square root of 2 by 2, we are going to get 6 square root of 2. According to the problem, the length of the extended segment is twice the length of the original segment.